Good day, everyone. Thank you for hosting today. I'm Jean Pierre Smith, JP Smith, Director of Stark Technologies. I am responsible for the development and the implementation of the new technology and also the new development of new technology within the Stark Group. Thank you, Multotec, for obtaining us this advantage here or the opportunity to present our latest innovations. What we're going to discuss today is revolutionizing efficiency measurements, real-time insight with real-time RFID tracers. So maybe just a short overview of Stark Group and what you think if you hear the name. So what we say here is rethink recovery. It's next generation solutions around ore sorting. So let's focus on the word around and specifically there. This is to provide solutions in new innovations, new technology, new ways of thinking of providing a solution around ore sorting. So that's where we fit into the picture. And then we combine these aspects in a way of thinking to provide a sustainable mining environment to improve efficiencies. So if you look into a world where mining is essential, and we know mining is essential, otherwise we won't be here, we want to do as little harm to the world as possible. So that's why we're saying using every opportunity to enable sustainable mining. Right. So a little bit more, we are around 8 locations around the world, 100 plus employees, 15 languages spoken. Some interesting facts there: 6 engineering disciplines, electrical, mechanical, process, civil, mining, and geology. And then with that, specifically for today, we have around 100,000 RFID tags in circulation. So maybe you can see around there some of the areas where we focus on, from Northern America down to the Southern African region. Good. So for today, we're talking about RFID traces and RFID technology. So how does that fit into today's topic? So we want to mine smarter with data-driven plant optimization. So we're looking at 2 components here. The first one is the tracer and then also the equipment of it. So what is an RFID tracer? RFID tracer is a component, or the tracer itself is a component that is weighted to the specific density of the commodity. So it varies in density, varies in size, and has a unique EPC value. So we're talking about the EPC is an electronic product code, which the RFID has. The RFID is a radio frequency identification component that's now integrated into this tracer, flow with the material and provide you accurate data of the physical material. So advanced technologies. So you've got commodity-specific particle size and density traces. This monitors the plant's performance or where the placement of that specific tracer is with real-time data. Then we move over to the sustainability, because we said we want to make mining better, right? Increase your plant's efficiency. So what you have, let's increase it. Optimize the process, reduce downtime, and then improve maintenance costs overall. So big summary over here of what RFID tracers does and do. So we're looking at the transformation process here specifically. So firstly, we would start with the advisory side. So where's the advisory? How does your process look? And then see where we can fit into that. So let's start at the resource tracking side. So post-blast polygon tracking, RFID traces spiking into the resource and tracking that from the resource directly into your plant. So then identifying high-risk areas, bottlenecks in your plant, and also material residence time. Then we look at the specific equipment as well. Product screening efficiencies, DMS performance tracking, and then sorter and auditing and optimization of that. Within that, and this is the most important part, the data accrual. So we collect this data and visualize it into a dashboard, for example, where you can have actionable data and tasks. That's a full loop back to the advisory side, having ongoing technical support here and evaluate the process and to optimize and then basically realize what your plant can do. We're taking what exists and trying to improve that, not necessarily to build something new. And this is where the RFID technology performs its task. So for today, this gives a nice overview of the capabilities of the product specifically, and it gives the way of thinking of what you can do to optimize your process. So for today, we're going to discuss on DMS performance tracking side, specifically on the cyclones and how it works and what information you can get from that and what efficiency measurements you can get from that. So density separation applications here. RFID performance tracking works for density separation methods in various equipment. So in your drums applications, your jigs, your cyclones. Because we're splitting on density, we can split with these traces the exact particle and know exactly where it was placed, either in your sinks or in your flows, either product or either waste, different sizes, and also collect that data and have it viewed onto an online platform. So some of the benefits by using RFID traces in your process, you have live running plant tests, so you don't have to switch off your plant. You can run the test immediately in real time. Application-specific particle sizes and density ranges from a wide range of commodities, and you can see exactly what's happening in your process and how your material flows, whether it's a maintenance alert, for example, or whether there's hang-ups in your plant, or even bottlenecks. This also provides real-time monitoring of your feed and your blend and what's coming into your plant. If you track from your pit up into your plant, you know exactly what's entering your plant, so you can optimize or change parameters accordingly. This is a modern technology, and we know this can be used to optimize the processes. And this is a performance-driven data where you have actionable data, efficiency curves, placement, and recovery percentages. So how does this RFID DMS process work? So let's look at the cyclone, for example. Let's go through the process. So like I said, we have specific density traces ranging with a wide range of densities. So it can be used for multiple commodities. So from a 1.1 to a 4.7 grams per cubic centimeter. These density ranges are fitted in the traces with an RFID tag, and then we put detection equipment onto that specific type of equipment, for example. So you'll see here the detection equipment that you have here is situated on floats, and your sinks, and then on your inlet. So we detect on 3 points where we have then can compare the results and where the placement of those traces are. Introduce the traces into the system with either a manual process or automated dispensing unit where you can track continuously on the process, or you can then put it into the system and see what your results are with real-time calculation with a central processing unit and then linked to the cloud interface. There you have your real-time results reporting reporting the information and also enabling real-time process control. And that has a full circle. So and I like to present this in a circle because it's not just a one-time thing. You have to do this continuously and improve where you see. Maybe do some changes on the system, change the pressures, change your medium, play around with the system and see what changes makes the process more optimal. If we go to the traces specifically, this is the side where I like to show because you can actually see how the traces look. We have now a size range of 4 to 50 millimeter in this on these traces. And like I said, a relative density ranging from a 1.1 up to a 4.7. Density increments from 0.05 relative density. So you can have a very tight tolerance there. These components are also lead-free. So we make sure that there's no interaction or contamination on environmental impact. And it's suitable for a quality control measurement. So determining efficiency, continuous monitoring, and then overall data collection into the plant. The equipment side. So what type of equipment is used to detect it? So you have a receiver and a transponder. So that one is the antenna and the other one is the physical tracer. So all these antennas are marketed and made in South Africa, in Centurion. We fabricate the component and then the antenna so that it detects and reads well with the physical tracer. So it's not an off-the-shelf component where you can just try and plug and play. It's specifically made for this harsh environment in this mining site, and you collect the data, and it's mobile enough to move around and have multiple detections, for example, on a mobile order. The polarization of the antennas are circular. The form factor is a stationary fixed form factor. Connector types are TNC female. We have a back panel mounted connection, so you can mount it, for example, onto a screen. You can mount it, for example, onto a conveyor belt, and it is easily interchangeable. The primary frequency is 950 megahertz to 990 megahertz, and we have a standing wave ratio of 1.3 to 1.5. So these antennas, like I said, are manufactured in South Africa. So it also enables you to have local support available, making sure that the information and the quality of the product is always maintained. So maybe just on the visual side, also do like to show this. This is also a very nice representation. So if there are anyone, please, this is a visual indication. This is not a CFD or a finite element analysis. Just shows the path of the material. And I always like to show this and how it's introduced into the process. So you can see the material coming in. Inside the material, we introduce the traces. All the traces are ranging from a 1.1 to a 4.7, and the traces are fed with the material. This is what makes this unique. You never have to switch off your plant to do these tests. It runs with the material. Because it simulates the size and the density of the material, it flows with it. It is also then detected with our high frequency antennas, where you can then place it either on the sinks or on the float side of the overflow on your discharge screens or your dewatering screens. There you can detect it and have a real-time data collection, providing you with a partition curve, your cut point, EPM, and your D25 and D75, immediately available for metallurgists, plant operators, even the CEO to have a view on your plant and make adjustments where according and where needed. I believe that's the most important part. Data collection and data aggregation. So yes, there are traces available. We call them dumb traces. Not that they're dumb, but they don't have intelligent information inside them. Where we can collect this information with the RFID tag and have residence time through your cyclone. We can detect how, if there's roping, for example, your near-dense material stays in the cyclone longer than your heavier or lighter material. There's a lot of information that you can track from it. And because it's data, it can be visualized as well. If you want a distribution table, you manipulate the data and view that onto your site there, providing real-time process conditions. So if you can collect information, for example, on your pressure, on your feed rates, how does that compare to that curve or your efficiency curve on that specific time? How did that influence the process? So now you can pinpoint areas of improvement. to maximize your recovery. So I understand that everyone wants to see how it physically works. So we provided a cold case study to provide a solution to see whether the technology actually works, right? So it's always nice to have the theoretical of it. Yes, it does work theoretically, but how does it work in the process? This is a cold case study that we did. And since you know, Johan de Korte was busy with RFID studies from the 1980s, I believe. It's been an ongoing process, but until now, the technology is commercially available and suitable for the market. We are also in a space where we want to use this technology to improve the process. So the goal and the aim was to prove that this modern tool and this modern RFID tracer does work in production. And I can provide an online efficiency curve in real time. They are the results that were obtained from this test work. We introduced the tracers into the process and had that immediately available. The tracers were combined in the flow, so you can see a 6 mil, 12 mil, 25 mil, and you immediately have your results available. It provides you a D25, a D50, as well as your D75, including your EP value, and you can see how it changes over the various sizes. So from a 25, 12, and 6 millimeter. We use Erasmus model fit to make sure that we have a smooth curve, but can also provide the raw data in a raw format where you can see what's happening. So you'll see on the 6 mils looks quite different than on the 12 mils, for example. The RFID tracers are a modern tool. It's a modern tool to help metallurgists ensure that the plant is optimal, efficient, and all the settings are maintained. So I believe that we can use this technology and this tool to improve the process. We have written a white paper on this, and this could be something that we could share in the link in this chat to have that as a case study, and what case study we did to see the potential revenue increase that this technology can improve on your plant and in your process. Thank you for this time, and I believe that if there's any questions, we can discuss that. And I believe that this technology is the way forward of producing and collecting efficiency results. Thank you.